evening to our lecturers for subject EFT 2143, Methodology and Scientific Research, semester September 2022 and 2023. Partial replacement of sand with glass waste of fine aggregates for structural concrete. Our group members consist of Ong Chun Hao as the leader. His metric number is J2080607, Daniel Hakimi bin Fauzai, J2080435, Chu Jiasi, J2080659, Tan Yongjin, J2080700, and finally me, Sharani Anapumpanchalaya, J200755. Especially thank you for lecturer, Prof. Dr. Juliati binti Muhammad. For presentation outlines, we have introduction, problem statement, objective, literature review, material and methods, and research flow chart. Thank you. For my part, I will talk about introduction. So we have normal concrete and glass for our research as a main subject to our research work paper. Normal concrete as 25 megapascal to 40 megapascal as a compressive strength, high durability, and high thermal resistance. When it comes to application, normal concrete used building and wall. As far as it has a high thermal resistance and high durability, it also has a disadvantage like less ductile, heavy and low tensile strength. Meanwhile, glass, it has high hard properties, high chemical resistant, and high pressure resistant. Glass also used to be in packaging, housing, and building. As far as it has good properties, glass is non-biodegradable as it sounds like a concrete or other degradable materials. It is also take 4,000 years to decompose. For our research study, we study about the compressive strength of the concrete with partially replaced sand with waste glass powder. So the problem statement we get from this research is that it influences the strength and workability of concrete, that is sand. So sand has high density, prompt to increase the slump values, but it has low compressive strength. Not only that, glass waste. To replace sand as the fine aggregate, that is the purpose we use glass waste. And not only that, to reduce the high density of the problem and issues. For objective, our objective for research is to study the compatibility of partially replacing sand with waste glass as the fine aggregate. Okay, it is our main purpose is to just replace the sand that we use as a waste glass, so the waste glass can be degradable. Okay. Not only that, to observe the most ideal composition among different percentage of replacing sand with waste glass as the fine aggregates. Thank you.
For the material, in this mini project, waste glass will be crushed into small pieces and grind it using grinding machine. Then we will get the material, which is waste glass powder. Then the other materials will be used in this mini project are cement, small stone, sand, and water. Next, metallurgy. First, material selection process, we will select the most suitable material depending on a range of parameters such as price, performance, and lifespan. Second, in concrete mix design, we using different ratio of glass powder and sand for 4 samples. Third, mix the all material together and stir it properly in concrete mixing process. Next, curing process. The process of curing involves maintaining moisture of concrete at the fresh state within a proper temperature and keep the hydration process going and provide the desired qualities of hardened concrete. Last, concrete will undergo some tests after curing process. For example, slump test, fresh and dry density test, and compression strength test. In concrete test, the slump test is to determine the consistency of the concrete at the fresh state. The fresh and dry density test is to determine the density of the replacement of fine aggregates by waste glass. Compressive strength test is to determine the ability of sample withstand under compression when test on the universal testing machine.
In this experiment, X-ray fluorescence analysis XRF is carried out to determine the chemical composition of our waste glass. And based on the chemical composition, we have concluded that the waste glass we use is soda lime silicate glass. This is due to the compound of silicon dioxide, which contains of the highest weight percentage, which is 88.50. Besides that, the magnesium oxide and aluminum oxide contribute the durability to the glass, and calcium oxide is generally obtained from limestone. And exactly, the chemical composition for SLS consists of all the compounds listed as the table. To observe the performance of the concrete, we have created 4 samples in order with the different weight percentage of the use of glass waste and fine aggregates. For sample 1 is the normal concrete mixed version. There are no glass waste added into it. And we observe that the surface are sticky and wet, dark brown color, and the voids are the most. For sample 2, we add up the glass waste to 10 weight percentage, and at the same time we decrease the use of fine aggregates. The surface for sample 2 is rough, brown color, and the voids are a lot. For sample 3, glass waste, the use of glass waste is fair, which is 20-20, and the surface we observed is smooth, milky white color, and the voids are less. For sample 4, we have increased the glass waste until 30 weight percentage and decreased the fine aggregates until only 10 weight percentage. The surface we observe are more smooth than sample 3, and it is white color, and voids are the least.
So I want to talk about slump test. The figure to show that when the percentage of the glass is 10%, the decreasing ratio in the slump is 23.4%. When the percentage of waste glass is 20% and 30%, the decreasing ratio in slump is 33.33% and 36.67%. Okay, first I want to talk about fresh and dry density test. The figure 3 shows that the decreasing ratio in fresh density. The figure 3 shows that the decreasing ratio in fresh density of 0% is 0% waste glass, 10% waste glass is 1.26. Decreasing ratio in fresh density, 20% waste glass is 2.26. Decreasing ratio in fresh density and 30% waste glass is 2.94. Decreasing ratio in fresh density. Figure 4 shows that the decreasing in dry density. The decreasing dry density that show that in figure 4 have 3 days, 7 days, 14 days and 38 days. Okay, now I want to talk about compressive strength test. First, according to the result, we found that 30% of waste glass compressive strength at gram after crying is most highest. This is because waste glass powder did not absorb water as fine aggregate.
My name is Daniel Kimi Bibosa. My nomenclature is J20800435. For the research proposal, first material selection, we use the silicate glass for waste material. In the part in grinding, we break into the glass into the small fragment, and we use a machine for grind into the glass powder below than 4.7 mm in size, and using the serving for powder form glass paste. After that, we mix it according to the rate we estimate, but for mixing all the material, for we left more than 7 days for curing the and complete hardening process. Finally, we test for sample with the universal testing machine.